All right, let's talk about the natural exponential function. To start, we're going to look at y equal ln absolute value x. Now remember the definition of absolute value. It's ln x if x is greater than 0, so you have a positive number in there. Remember, you can only take the natural log of a positive number, and it's ln of negative x if x is less than 0. Now let's talk about this. If x is less than 0, then x is negative. And you're putting a negative and a negative together, so you are taking the ln of a positive number. So we're okay with that. Okay, again, let's look at the derivative of ln absolute value x. So let's look at the derivative of that. Ln x prime x greater than 0, ln of negative x prime x less than 0, and that's going to be 1 over x, x greater than 0. It's 1 over the function times the derivative of the function. The derivative of negative x is negative 1, which is 1 over x, x less than 0. So that's where we get that the derivative ln absolute value of x prime is 1 over x as long as x is not 0. And that means the integral of 1 over x dx is ln absolute value x plus c. So that's really, really important that you need those absolute values. Now sometimes you'll see the answer and it won't have the absolute values, and that's not wrong in certain cases. So for an example, if you look at ln of x squared plus 1, x squared is positive, you add 1, it's positive, so inside there's positive, so you're taking the natural log of a positive number anyway, so you can drop the absolute values. So if you're sure that this inside expression is positive, then you can drop the absolute values. So again, there are some things we know. We know ln x is always increasing because the first derivative is positive for x greater than 0. And we're going to say f of x is ln x. And here's the curve. Here's what the graph looks like. We know it's 1 to 1. So it has an inverse function. A function has to be 1 to 1 in order to have an inverse function. So we're going to call the inverse function exp x, and that's going to be f inverse x. Now, the nice thing about this is we can graph this, because if you remember, if we take the graph of f of x and we reflect it across the line y equal x, you get the graph of the inverse. So this is f inverse. Let me make that a little clearer. Which is exp x, that's what we're going to call it because it has to have a name, or we're going to give it a name. Also, this point's 1, 0, so the point on the inverse is 0, 1. All right, well, let's look at some other properties that we know about, or other things that we know about inverses. If we have ln of x equal y, then since exp is the inverse, we know exp of y is equal to x. We also know the ln of 1 is 0, so that tells us that the exp of 0 is 1. So that tells us that the point 0, 1 is on the graph of F inverse. Okay, we also know ln of E, remember E was 2.718, not never ending, is 1. So that implies that exp of 1 is E. So that tells me that the point 1e is on the graph. Okay, so if we have ln e to a power, we know that that power comes down, and that's n ln e, but that's 1, so that's n. So that tells us that exp of n is e to the nth. And what that, all these point to, and which is going to be end up being a true statement, is that our inverse function for ln x is e to the x. Remember, e is that number 2.718 and non-repeating, non-terminating. So now we know that e to the x and ln x are inverses. That means they undo each other, which if you put them together as functions, we should come back to x as long as x is greater than 0, because you can't take that ln of a negative number. And ln of e to the x, again, if you combine those two functions in a composition, that's x for all x, because e to the x is always positive. So the limit of e to the x as x approaches negative infinity is 0, and the limit of e to the x approaches positive infinity, is infinity. And that comes from the graph. Remember, we know what the graph looks like because it's the inverse of ln x. It's reflected across the y equal x line. So this is the graph of y equals x. And as you're going to x goes to negative infinity, this is going to 0. And x goes to positive infinity, this is going to positive infinity. Now, let's look at the derivative. The derivative of e to the x. So we're going to let y equal e to the x. We do the ln on both sides. I'm going to take log differentiation. And ln and e are inverses, so they undo each other, and we just get x. We'll do implicit differentiation. Getting y prime over y equal 1. So that gives us y prime equal y. Well, that's saying that the function y is equal to its derivative. So the derivative of e to the x is e to the x, and the derivative of e to a function, u is a function of x, using the chain rule, is e to the u times the derivative of the exponent. So this is the chain rule. And we need to be able to use those two formulas. And then finally, the integral of e to the u du is also e to the u plus c. So that's an integral formula for the exponential function. And we call e the natural exponential function. Okay, well, I hope this helps when you look at some of the exercises.